Hey everyone, and welcome back to another episode of the Weekly Coder. I'm Chris, and what we're going to do today for this week's tutorial, we're going to implement another feature to our Tetris clone, and that feature is, we'll call it a Ghost Tetromino. And I'm sure everyone is familiar with it. I don't know if that is the proper terminology. But that's what we're going to go with. We're going to call it a Ghost Tetromino. And basically what that's going to do is it's going to be a duplicate of our currently active Tetromino piece, but that duplicate is going to go ahead and show us where our Tetromino will land before we place it down if we keep going down the same path that we're going. And I'm sure you've all seen this in other Tetris games. And, this was a subscriber request, so I thought I'd go ahead and do it. It's not going to be anything too difficult or complicated. We're going to be creating a new script, and that is going to be called Ghost Tetromino. And that's going to apply to all of our existing Tetrominos, but we are not going to assign that script to our Tetrominos in the inspector. That is going to happen in code as we spawn our Ghost Tetromino. Okay? So the first thing we're going to do, just so that we don't forget, is we're going to create a tag for our Ghost Tetromino. Okay? So we'll go up to Edit, Project Settings, and Tags and Layers. We're going to go ahead and expand tags. And here we've already got our current active Tetromino and current saved Tetromino. And in case you're not following along in the series, this was from a previous tutorial where we've added the save Tetromino or hold Tetromino feature to our game. So these may or may not apply to what you're currently doing with the Tetris clone. So just know that these are there for that purpose. So we're going to go ahead and add a tag, and we'll call this one current Ghost Tetromino, okay, to basically keep up with our naming standards here. Alright, so now that we've got the tag, we're going to go ahead and go into our scripts folder. I'm going to do right click, click on create, and then, go over to C# script. And then we're going to name this Ghost Tetromino. Tetromino. Okay. Now let's go ahead and open that up, launch that in MonoDevelop. Okay. So we've got a pretty empty script here. And the first thing we're going to do, we're going to want to do, is we're going to want to set this tag, the tag property of this game object, equal to current Ghost Tetromino, because the instant that we instantiate this particular Tetromino with this Tetromino class, we want the Tetromino to be tagged with current Ghost Tetromino. Okay, and since that this script is going to be a component on our Tetromino game object, we can just go ahead and call the tag property of the game object and then assign it there. Okay. And the other thing that we're going to want to do is we are going to want to fade the change the alpha value of our Ghost Tetromino to be kind of see-through, right? We want it to be a little transparent so that we don't get confused with whether or not it's an actual Tetromino or if this is just the Ghost Tetromino showing us where we're going to be. And we can simply do that by using a for each loop. And we're going to get the Minos, okay, in the current transform. So basically we're going to get each individual Mino that our Tetromino is comprised of, because they're all individual objects, okay? So we're going to get the transform of those, and then we're going to be able to get the use the get component method of our Mino transform. And we're going to get the sprite renderer, okay, because that's responsible for all of the sprite properties, okay. And the property that we're going to want to change on the sprite renderer for our Mino game object is going to be the color property. Okay? So we can't directly edit the alpha property of the color property. So what we have to do is we have to pass in a whole new color object. So we just say equals new color. Okay? And then we just specify 1F, 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 because there are no changes. We want to just keep the current colors as they are, okay, RGBs. And we're going to change the alpha, which, as you can see here, okay, the A is for the alpha component. That is our last component in this method. So we're going to set that to 0.2F, okay, to give it a nice transparent look. All right. So the next thing is we need to create some methods. One, we need to create a method called follow active Tetromino. And basically what that's going to do is that is going to be our method that this ghost Tetromino is going to use to determine what position the currently active Tetromino is at, and then we're going to set the position of our ghost Tetromino to the same position of our current active Tetromino. Okay. So the way we do that is we set transform.position. So the transform of this game object, we're going to set its position to game object, and we're going to use find game object with tag, and then we're going to use the current active Tetromino tag to find the Tetromino that's currently active. We're going to get its transform and its position. Okay, and we have to do the same thing for the rotation. Okay, because the player may rotate the piece, and we want our ghost Tetromino to basically mimic that. So find game object with tag again, current active Tetromino transform dot rotation. Now, if you really want to optimize the code, okay, here's one thing that we could have done. We could have done transform current active Tetromino transform equals game object dot find game object with tag current active Tetromino, okay, dot transform. This way we only have to run this once, okay, and it's going to go ahead and assign that to this. All right, better yet, nope, let's keep it like this. All right, so then instead of doing this game object dot find game object with tag current active Tetromino transform dot position, all we have to do is current active Tetromino transform dot position, and here again we can do current active Tetromino transform dot rotation. Okay, so for the most part, when you're writing code, you're not going to do this kind of on the fly optimization, because when you're writing code at first and you're trying to get something to work, you want the most simplest code that you can, the most readable code, and then later on, after everything is working, then you can go back through and say, oh hey, I can optimize here or I can optimize there. So just a note, don't try to be too worried about optimizing your code as you're writing it, because that tends to get messy. You tend to bury your code in unreadable or more difficult readable code, and you're just gonna have a hard time debugging anything. So, but this is okay for now, right? We'll just leave it this way. So, and this follow active Tetromino, we kind of want this to happen all the time, right? Every frame update, we want to check and see where's our Tetromino at, or active Tetromino at, and we want to say, oh, we want to be at that exact position, okay? And I know you're thinking, no, we don't want it at the exact position, because that's not going to give us anything. We want it at the exact X position, the same horizontal. We want it at the same rotation, but we don't want it in the same Y position. We want it all the way as far to the bottom as it can go, right? Until it reaches another piece or the floor. So, and that's going to happen in our next method, okay? I'm going to call this method the move down method, okay? And in this method, every frame, we're going to say, hey, while, oh wait, kind of jumped the gun here. We need to create another method, and that's a method that we're actually using in our Tetromino method, and it's called check is valid position. Okay, and here's another way to optimize. This check is valid position, I believe, is present in the Tetromino class, and it's also present in the game class. So we're writing the same method over and over and over again. And instead of doing that, we could actually write this method in a class, and let's call this class, let's call it utilities, or convenience methods, or helpers, or whatever we want to call it. And then we would make that class a public class, along with a public method that you can then just call from this class, and that way we could call that method from every class, and we wouldn't have to worry about rewriting it in every one of the classes that we needed it in. Okay, so in our check is valid position, all we're going to do is we're going to do a for each loop, and we're going to do the same thing, transform Mino in transform. So we're getting all the individual Minos that make up our Tetromino. We are going to then use the check is inside grid method that is in our game class. Okay, so we're going to check to see if it's inside the grid. So if find object of type game, so we're going to find the game class. Then we're going to do is check is inside grid. Right, we're going to pass along the position, which we should have created first. All right, so here we're going to do vector2 position find object of type. We're going to use the round method that is also in the game class. And we're going to get the position of the current Mino that we are traversing over from the transform. Okay, so then we do find game object of type game, or find object of type game, check is inside grid, and we're going to pass the position variable that we just created. Okay, and let's see, yep. And if that equals false, then we will just return false. Because obviously, if we're not inside the grid, then we want to say, oh, we're not in a valid position, so we return false. So this one would then return false, and none of the other code would run because the method would return, and that would be the end of it. Okay? So let's say we don't return false. Let's say that we are inside the grid. All right. The next thing we're going to want to check is to see if the Tetromino is basically interacting with the currently active Tetromino. Because if the, let's say we set the position of our ghost Tetromino, and we set it equal to the position of our actual Tetromino. So this is the ghost Tetromino, this is our actual Tetromino. So if we set it equal to the position, what's going to happen, because in our move down method, it's going to check to see, hey, is there a piece below me? And this thing is then the ghost is going to say, oh yeah, there is something below me because I'm touching it, so I must move back up. So then the ghost piece goes above our actual Tetromino, so we don't want that. Also, if the ghost piece is down here and the actual piece is falling, it's going to interact with the ghost piece, and the ghost piece is just going to go up. So we don't want that behavior. So we want to just lose all interaction between the ghost Tetromino and the actual Tetromino, the actual Tetromino, the active Tetromino. Okay. So the way we do that is we do another if statement, and we're going to do find object of type game, and get transform at grid position. Okay. And doesn't equal null, making sure that we're actually checking to see if a transform, if a transform is actually currently at the position in that grid. Because if there isn't, then we don't even care, because we know that we're not interacting with anything because there's nothing there. And then the other thing we want to check is find game object of type game get transform at grid position, position dot parent. Okay, so we want to get the parent tag, all right, because when we are getting transform at grid position, we're getting the transform, okay, which is the current Mino. That's not the whole Tetromino, it's just a Mino that is stored at that, the transform of the Mino that is stored at that grid position. So what we need is the parent of that Mino, which would then be our Tetromino, and then we need to find out what the tag is, right? And if the tag equals current active Tetromino, then we want to return true. Because if it's interacting, if the ghost piece is interacting with a currently active Tetromino, then we want to say that, oh yeah, we're still at a valid position, so we can keep going, right? We return true, and that's the end of that method. Finally, we need to double check and make sure that it's not interacting with itself. So find object of type game get transform at grid position, make sure that that doesn't equal null, and find game object of type game get transform at grid position dot parent, okay, doesn't equal transform. So make sure that that doesn't equal this transform, and if it does, then we return false because we are not in a valid position. All right. Otherwise, if we get through the entire for each loop without any issues, we want to go ahead and return true because we are in a good position and our Tetromino, our ghost Tetromino, can keep moving down the way it's supposed to, right? So the move down method is actually quite simple as well. All right, we're going to use a while loop, and we're going to do check is valid position, right? So while the position is valid, okay, we want to transform dot position plus equals new vector 3 0 -1 and 0. Okay, so and what this does is that every frame this move down method is called, and so for every frame we're going to run this while loop, okay, and it's going to increment by a -1. Say we're going to move 1 unit down every time this while loop runs, okay? So it's going to continue to run, okay, until this returns false. So once this returns false, we are no longer going to continue to move our ghost piece down, right? So then when we're done with that, we want to make sure that at the end, if not check is valid position, then we want to transform position plus equals new vector 3. We want to just move our piece back up 1, because remember, we're going down and down and down and down and down until basically we're colliding with something. So when we're at the point when we're colliding with something, we're already on top of something. So we want to move our piece back up by 1, so that in the next time the frame gets drawn, our piece doesn't look like it's inside of something or like on top of something, right? So that's basically it. So then what we do here is we call our move down method. Okay? So brief overview again. We're going to move our Tetromino down, okay? Constantly moving down. It's always moving down, okay? While this method returns true. At the same time that it's moving down, it's also, well, first, it's actually being set to the position, right? So we're setting it to the position to the currently active Tetromino, which, if the currently active Tetromino is here, and our ghost piece is here, over here, or wherever else, it's saying, oh, hey, we got to put you up here with our current active Tetromino. So then what happens is we say, oh, well now we want to move down. So now we're only going to move in the Y direction while the while loop returns true. Okay, while loop returns true. Okay, we're at the bottom. We're on top of the piece. And then it's saying, oh, okay, well we're now outside of the grid, or we're interacting with another Tetromino. So we're going to get out of this while loop, and then at that point, we're going to check and see if we're not in a valid position, which we aren't. And if that happens, we're going to go ahead and move back up one. And then at that point, we are going to go on and finish with the rest of our code, and that includes redrawing the screen. So our piece will appear as though it is always at the furthest to the bottom as it can be, all right? So I hope that I explained that well enough for you guys. That is our Ghost Tetromino script, and that is all we need to do in there, okay? So, for the rest of the game, we need to actually go into our game class, okay? And there are a few things we need to do here. Let me just review what I've done. Okay, so here where we've got our preview Tetromino, next Tetromino, and save Tetromino, we are going to go ahead and create another game object, and that will be our Ghost Tetromino. Okay, so we've got a Ghost Tetromino, and I spelled private wrong, and still wrong. There we go. All right, and let's see what else. Okay, here we go. So we're going to go to the method where we spawn our Tetromino. Okay. And we're going to create another method, and we're going to call this, make it public void spawn Ghost Tetromino. Okay. So because every time that we spawn a new Tetromino, whether it be from swapping a Tetromino or spawning a new one to fall from the top after we've landed one, we have to also spawn a new Ghost Tetromino that is basically a replica of the Tetromino that we've spawned. So here we're just going to do destroy game object dot find game object with tag current Ghost Tetromino. Okay. And then we're going to instantiate the new Ghost Tetromino. So Ghost Tetromino equals, okay, so now it didn't like that. Ghost, okay, did I not create that correctly? Oh, I didn't. Lowercase. Alright, let's go back to here. Alright. Ghost Tetromino equals, and we're casting a game object to our instantiate method. And we're going to instantiate it with next Tetromino, which is actually our current Tetromino. We're going to pass along a position of vector2, 5.0f. And actually, let's just use our next Tetromino dot transform dot position. Okay. And of course, quaternion dot identity for the rotation. Okay. And now we're going to destroy, and this might seem a little odd, but we are destroying a component of the game object. And the one we're destroying is the Tetromino component. That's our Tetromino class. and then we're going to add a component to our Ghost Tetromino, okay? And that is going to be the Ghost Tetromino class, okay? So now our Tetromino has a completely different behavior than it did before. Now it's going to actually act like a Ghost Tetromino, okay? So then the only thing that's left to do here is at the end of this method, we want to call spawn Ghost Tetromino. And then at the end of this method, same thing, we want to call spawn Ghost Tetromino. And just so that we keep things interesting and error-free, it's possible that there is no current Ghost Tetromino because we don't start the game with one. Yeah, we don't start the game with one. So this is the first thing we call in spawn, we destroy. So we're assuming that current Ghost Tetromino already exists. So we need to check to see if it exists before we destroy it. So we say if game object find game object with tag current Ghost Tetromino doesn't equal null, then we destroy it. Simple enough. All right. So let's see what happens. That should be it. I'm pretty sure of it. Let's see. All right, let's click play. And we have compiler errors. Wonderful. Okay, where are we at? Our compiler errors. What's going on here? Unexpected symbol, expecting, semicolon. Why not? Oh. What am I doing here? Okay. So let's save that, go back into our game. And you know what? Let's just load up the correct scene here. I'm gonna go to the game menu. Alright. So we've got our level selector, play, high scores. Let's play. Alright, so there's our ghost piece. Now when we're moving left and right, our ghost piece follows us around. Okay? And when we go down, we can go right through our ghost piece and it's perfect. Okay? And it rotates just like it should along with our other piece. And it tells us where we're going to end up. See, this piece right here, this is why it's good to have that save method. So we can press space and it'll swap out that piece and give us this one to use, which is much better. Alright, so we'll put this one here. And then we're going to save the long piece, trade it out with this one. Oh, we forgot one thing. Did you notice how when we swapped, we didn't get a new ghost? So we actually have to go into the script once more. Thought we were done. And in Save Tetromino, we actually have to add in here, we have to add spawn Ghost Tetromino. Because we don't have to add it here, because there's no Tetromino currently being held. So we're not swapping, we're just saving, and we're already calling spawn next Tetromino. Here we're not really calling spawn next Tetromino because we're just swapping one piece for another. Okay, so we're not actually spawning something new. Here we have to spawn something new because nothing existed before it. Alright, so let's go ahead and save that and give it another try. Let's click play. I like to save the long pieces. Makes it easier to get Tetrises. Like, now. Now's a good time. And watch, we're actually going to clear all the lines are going to clear. This, like, never happens. Okay. Bam. We should make a new score multiplier for that. If we clear all the lines and then there aren't any left on the screen. What do you guys think? That'd be fun. Okay. Save you. Put you. You know something? There's something I've been wanting to fix, and it's been driving me nuts. Is the audio starts playing, but then it doesn't loop, so we only get that first, 20 or 30 seconds of audio, and then it just stops, and we have no more music. So anyways, this is working just like it should. I'm going to fix that audio really quick, if I can remember where it's at. Main camera? Is it the audio listener? Nope. It is on the game menu script. Nope. Event system. Okay, where is my audio? Oh, we're in the wrong scene. Alright, so let's go to the level scene. It's probably on the main camera. Nope, it's still not on the game script. Game script, there we go. And a loop. Alright, perfect. Now, if we go back to our game menu and click play. Now our sound should loop. Save it. Yeah, it looped. Did you guys hear it? Please don't make fun of my Tetris skills. Oh. And maybe something else that we should do in this tutorial, because I'm sure someone's going to ask, is we should make it. Oh, that's not a good idea. We should make it so that. Man, I hate it when it happens. So that we have a button that'll just drop the piece. Yeah, I'm really screwing up here. Okay, so let's think about how we can implement that. All right, and I'm thinking that it's something that we should put into our scripts, or yeah, definitely in the scripts for sure. It's something that we should put into our Tetromino class, because that's where we have most of our other movement. Okay, so here in our check user input method, what are we using? We've got right arrow, left arrow, down arrow, right arrow, left arrow, up arrow, down arrow, fall speed, and we're using spacebar in the game class to swap pieces. Okay, I think we should use spacebar to drop the piece, and maybe shift. Let's call it left shift, if that's available. Alright, so let's go back in the game, and let's go into our, let's see, check user input, key code dot left shift. And just to be consistent, or input dot get key up, key code dot right shift. Okay, then this should make us swap. So let's first test that, because I haven't tried any of this and I don't know if it's going to work or not. So this is kind of just a thought I had as I was making this just now. So left swaps, right swaps, okay. Alright, so now let's go back into our Tetromino class. Now we are free to use the spacebar. So we'll just say if input.getKey up, keycode.space, we want to call a method called move down now. Nope, let's be more like, let's call it slam move, slam down. Okay, slam down. All right, so slam down. And you know, it's going to be really easy because we're going to do something very, very similar to how we're moving the ghost piece down. So basically what we do here is, let's make that method right here, slam down. So, what? Oh, gosh. Right. Public void, slam down. All right, so while check is valid position, we want to transform dot position plus equals new vector 3, 0 on the x, -1 on the y, and 0 on the z. Okay. And then if not check is valid position, meaning that it's returning false, we are in a bad position and we need to back out, then we do transform dot position plus equals new vector 3, 0, 1, 0. Okay, so that should do it. Now let's play some intense Tetris. Okay, that did not work how I'd like it to. And why did that not do it? There is a slight problem. And that problem is move down is still being called every frame. So it's possible that, okay, so that the only time it should only be doing it to the currently active Tetromino. You press the spacebar and it moves down until it can't anymore, and then it goes back up one, but then it immediately goes to game over because there's a game over condition. Okay, so when is it game over? It is game over if a piece is above the grid. So and the move down so really what we should do is we should disable move down if we're slamming, right? Because we don't want to move down and slam at the same time. So let's do this. Bool slammed equals false. And then here we do slammed equals true. And then here we do if slammed, then return. So we don't want to run the move down function if we're slamming. Sounds about right. Okay, so let's try that. Play, slam it down. Okay, so new problem. Now that we have that working, we're actually never ever hitting the ground because slammed is going to equal true. So we have to set slammed back to false. Yes. Okay, so let's do it this way. So if slammed equals false, then we still return, but then the next time this runs, slammed will be false, and then this can run fine. And it'll trigger the piece falling and then call the next piece. Let's see. Yeah, something's just still off a little bit here. Is it because, hang on. Okay, so we've got our square. Let's just see what's going on here. Okay, so we've got that square, we've got the T, which is the next piece. We've got the ghost Tetromino, because that's got the ghost Tetromino script on it. We've got our square here, which has the Tetromino script. So, you know what we need to do is we need to check and see back in our Tetromino class, let's make our slammed boolean, let's make that a public. I'm a little confused here. Alright, so we play, and then we slam. So then we're slammed. Okay, so we've got our L clone, which our T, our L, our Z. Okay, Z now has a property of not slammed. L clone, which is not our ghost, has a property of not slammed. This because it almost seems like this is hitting this one. Let's step through. We're stepping through one line of code at a time here. This is what it's like troubleshooting code. What I really need is I need to know which code we're actually stepping through right now. Oh, we went down one. So that means we are currently in this code where we're moving down. So we're not above the grid, and the only time game over is actually called is if we are above the grid. So what is it finding that's above the grid? It's this game object, so that we're passing in. So it would be this one that's above the grid. But it's really not. Okay, more weirdness. It's moved down one more. I wonder. Huh? Wow. Okay, so it just stops. It's like, okay, I'm just gonna stop right here. What? The only way that could happen is if check is valid position is returning false, meaning that there's something there. That's exactly what happened. Look. All right. So this is how it goes. Our Z was here, right here, when we dropped it. Right? So what happened after we dropped it? Nothing. We didn't update the grid. We didn't do anything else. We were just saying, oh, we're just going to drop. That's it. Nothing else. So then the last grid update position is right here. So it thinks there's a piece right here. So it's going to just stay right there. And then this is above the grid. So let me just demonstrate that. We're going to go down. And every time we press down, we update our grid, right? So let's just say this is our last position. We're going to go right here. This is right here, right about. See, it even shows us. The ghost is telling us where that T piece was last before we dropped it. So now we're stuck here. Alright. So we gotta fix that. Alright. Probably a good thing I did show you guys this because it would have been just a little more confusing. So let's go in and let's go to our slam. Well, yeah, move down would work too. We're using this right here to update the grid. So basically, we need to just call update grid. And we need to do that. We could probably do it here because that's where its final resting place is going to be. So let's have a look. And if you'll remember, the grid that I'm talking about is our multi-dimensional array that we're storing our transforms in to make all this work. So drop that, and drop that, drop that, drop that, drop that. Okay, this does make for much quicker gameplay. There's something I don't like here. There's a lag in the time that it drops down. So we need to make that piece land immediately. So let's go back to mono develop and let's have a look and see what we're doing in our move down. First of all, we can get rid of this whole slammed. We don't need that anymore. Now that we know what's actually going on, let's get rid of that variable up here too. Oh, we don't care if we slammed the piece. And we'll also have to get rid of it right here. Okay, so no slamming. Well, we're slamming, but okay, so moving down. Here we spawn the next. We play the land audio. So basically, we want everything except we want to call delete row as well. So we want all of this stuff right here to happen. Okay. And here. So let's play. Hey, there we go. Instant. There, look at that. Perfect. Swap. Oh. Okay, well, you know, that's what you're gonna have to... You're gonna have to get used to that. That happens. Okay, I am completely messing this up now. I'm sure I can redeem myself. Oh, maybe not. What? Yeah, break here. Really? It is just not letting up this game. Alright, anyways. Wow, lost horribly. Anyway, so that's that, and I hope that you guys have got everything you needed out of this tutorial. You actually got to witness me troubleshoot a little bit and figure out how to how I analyze problems and work through them to find a solution, which is good because, you know, I never usually add that to my tutorials. I kind of just plan everything out ahead of time, you know, work out all the scripts, go through and debug everything, and then when I have everything the way I like it, then I kind of go in and you know, try to replicate that through a tutorial. I've never, well, a couple times, but I've never really run into a problem like this where I'm like, oh wow, okay, how do I fix it? What do I have to do? And you know, the good thing with coding is when you're writing any kind of code, it's all going to follow a specific process. It is all going to always be run in order, and all your job is to make sure that things get executed in the right order and that everything is executed as it should be. Machines do what you tell them to do, not the other way around. So whenever there's a problem, it's most likely a human error. There are rare occasions where you're going to have glitches because there are memory faults or things like that that you just can't get away from, but that's faulty hardware. That's not your fault. So that does happen. Not as much anymore as it used to, but it can still happen. Um, so in any case, I'm gonna just end the tutorial there because, in my opinion, this thing has gone on longer than I wanted it to, and I'm gonna finish my beer. A little warm now. Anyways, I know I've said anyways like 1,000 times now, and I'm totally not going to cut it out of the video. I'm not going to edit it. So what I may do though, for the people who are impatient and don't want to see the troubleshooting part, is I'll add a little start position and an end position. I'll tell you exactly where to go to fast forward through all the troubleshooting to the final solution for everything. So, because I'm a nice guy, and I honestly wouldn't want to listen to myself for an hour trying to find 15 minutes? Okay, maybe 10. Trying to find a bug to fix an issue. So I am totally sorry for that if you guys hated it, but it is a learning experience, and like I said, anyone who codes is going to have problems. You're going to always troubleshoot and debug. It is just part of what coding is about. I don't think there are any perfect coders out there. I can't imagine a world where there's someone out there who codes an entire game without a single mistake with completely optimized code. I find it very hard to believe. You're always going to make a mistake somewhere, and you're always going to have to find out why and what you missed. Because as humans, as people, we're just not perfect. Alright, so anyways, enough rambling on. Like and like, thumbs up, right? Like, comment down below, subscribe to the channel. We've been doing really good this month. We've got a lot of new subscribers, so it means a lot more a lot more people coming in and enjoying the content. I've had great communication from everyone, which is always awesome. I love interacting with you guys, and keep the questions coming. I'm always available to answer them. I try to always be available to answer any questions that might come up. Sometimes it might take me a day or two or a week to get back to you, but I will most likely always get back to you, okay? So anyways, enjoy your weekend, everyone, and I will see you next week.